Hi, everyone. Thank you so much for joining today. We're just going to give a moment for everyone to log into the Zoom before we get started. Okay, it looks like we have a good amount of people on now. So hello, everyone. My name is Courtney Brown, and I'm a Senior Marketing Manager here at EDB. I'll be your host for today's webinar, Database Dumps and Backups. I'm joined by Karen Jex, Senior Database Consultant here at EDB. Before I turn it over, I just want to go through a few housekeeping items. This presentation is being recorded. We're going to share the recording along with the slides after the broadcast to the email address that you used to register. All of your lines are currently muted, but if you have any questions, feel free to submit it in the question panel at the bottom. We expect the presentation to last most of our time today, but we'll allot any extra time to Q&A. And if we don't have time to address all of your questions, we'll follow up individually after the session. And with that, I'm going to hand it over to Karen. Thank you.
Hi, thank you, Courtney. So welcome to this Database Dumps and Backups webinar. We're going to have a look at the differences between a physical backup using tools like Barman, BART, Barman, or PG Backrest, and a dump or logical backup using tools like PG Dump. We'll review the advantages and disadvantages, the key considerations, and the tools that are available to us for each of the methods. But first of all, for those who don't already know me, who am I? I'm Karen Jex, Senior Database Consultant with Enterprise DB. I live in a small village in the French Alps with my family and our rescue dog, Belle. I love cycling, mountain biking, and skiing, as you can see from the photos that I've shared. I started out my career as an Oracle 7 DBA and gradually became an Oracle 12 certified DBA. In that life, I spoke at several UK Oracle user group meetings and conferences. I started working with PostgreSQL databases a few years ago after approximately 20 years as an Oracle DBA. And as I say, I'm now a senior database consultant with Enterprise DB. I've been with EDB for just over a year now, and I love the fact that I get to help lots of different clients to get the best out of their databases, whether it's installing and configuring databases, designing architecture, or advising clients on best practices. So this just shows an outline of our agenda for today. So we'll look at why we take backups, why we might need to recover our database, what are our recovery requirements, the different backup methods, what comprises a backup strategy, and then some of the different backup and recovery tools. Before looking at the different types of database backups, it's important to consider why we actually take backups. It's not just for the fun of scheduling some extra processes or to use up our storage quotas. Backups themselves are a means to an end. What we really want is the ability to recover our database, and specifically the data in our database, if something goes wrong. We'll look at what that something that goes wrong could be a bit later. Data is almost always critical to an organization, and we need to know that it's safe and available. So backups enable us to safeguard critical business data and to recover from database failure. In fact, rather than thinking in terms of implementing a backup strategy, it's actually more useful to think of implementing a recovery strategy, which will be supported in part by our backup strategy. An important point to note is that your recovery strategy needs to be tested. This is important because, firstly, the only way to be 100% sure that any given backup can be restored is by restoring it. And secondly, if you need to restore a database because something's gone wrong, it will be an emergency. It will most likely be the middle of the night, there'll be no one around to help, and there'll be irate users or managers desperate for the database to be back up and running 10 minutes ago. You don't want to be trying out your restore procedure for the first time in this situation. You want to have done it many times before and know exactly what you're doing. I liken this to putting snow chains on the car. It's much better to practice putting them on calmly at home before the winter, rather than trying for the first time in a snowstorm in the dark in an emergency. I've already mentioned that we want to be able to recover our database if something goes wrong. The something that goes wrong could be, for example, the database server has crashed, the storage array has failed, a batch process has incorrectly modified data, human error, or worse, willful destruction. For example, someone's dropped a table or modified data, or there's a corrupted data file. In each of these scenarios, we want to be able to recover our database to a point in time just before the point of failure. In addition to these disaster recovery requirements, we may also want to be able to create clones of our database for development or testing purposes. This will generally come with requirements to remove or obfuscate confidential data, so it won't usually be a simple backup and restore process. In order to determine a recovery strategy, we need to look at our recovery requirements. There are a few main criteria to consider. Maximum permitted data loss, also known as RPO or recovery point objective. This answers the question, what's the maximum amount of data that we're permitted to lose? The RPO could be expressed in milliseconds or even as 0 for critical databases, or it could be expressed as a number of hours or even days for development databases. The maximum time to recover, also known as RTO or recovery time objective. This answers the question, how quickly should we be able to recover? The RTO determines the maximum amount of time that it should take us to have the database up and running after a failure. As with the RPO, this could be expressed in milliseconds for critical databases, or it could be hours or days for non-essential databases. Unfortunately, even databases are governed by the laws of physics, and although we can approach an RPO and an RTO of 0, we can't guarantee true completely 0 downtime or 0 data loss. We also need to look at backup retention. How far back into the past should we be able to go in case of failure? Do we want to be able to recover from an issue that happened 2 days ago, a week ago, or even a month ago? Note that most disaster recovery strategies won't be based solely on database backups. For example, applications that require continuous availability, i.e. an RTO of 0, a backup strategy alone won't be sufficient. It will also be necessary to implement methods such as replication to one or more standby databases to ensure that there's always an up-to-date copy of the database that can take over in case of failure. I mentioned that here for the sake of completeness, but those methods are out of scope for this webinar. So now that we've considered why we want to take backups, i.e. in order to be able to restore our database, we can look at the different methods available to us. We can take either physical or logical database backups, and the physical backups can be either offline or online. We can take advantage of continuous archiving, and we can consider the potentials and pitfalls of storage snapshots. And we'll have a look at each of those methods in more detail. Excuse me. So a physical backup is a file system level copy of the files that comprise the database cluster, i.e. the contents of the data directory. A physical database backup, as I've said, can be either online, where the database remains open and accessible to users during the backup, or offline, where the database is shut down during the backup. Physical backups have a number of advantages. They're generally much faster to restore from than a logical backup. They can allow point-in-time recovery as long as we archive our walls. And they can allow incremental as well as full backups. The main disadvantage of a physical backup is the lack of flexibility. The entire database cluster must be backed up and restored because it's a physical copy of our data files. Although we'll see later that the PG Backrest tool actually contains a mechanism that allows recovery of a specific database. So an offline backup is one in which the database is shut down in order to perform a clean copy of the database files. The steps are shut down the database cluster, copy the database files by whatever means we choose, and start up the database cluster. This gives us a snapshot of the database at a particular point in time. The advantages of offline backups are that any tool we choose that enables a copy of the database files, CP, rsync, storage to snapshot, can be used to perform an offline database backup. We don't need any special tools. Since there are no changes occurring on the database during the backup, there's no need to back up the associated WAL files in order to obtain a consistent snapshot. On the other hand, the significant disadvantages are that the database is shut down and therefore unavailable during the entire backup. Also, the point-in-time recovery isn't possible. A restore can only be performed to the specific time at which the backup was taken. So as a result of these constraints, it's extremely rare to see offline backups used in a production environment. But they may be implemented in development or test environments where a daily or weekly snapshot of the database might be sufficient. Just as a reminder, before we start talking about online backups, I've already mentioned WALs a few times, so I'll just briefly recap the purpose of WAL files and WAL archiving. So WALs, or write-ahead logs, are files in which database modifications are logged before being written to the data files. The WAL level parameter determines how much information is written to the WAL. If this is set to minimal, only the information required to recover from a crash or immediate shutdown is stored. If, however, we set the parameter to replica, which is the default, or to logical, then we store enough information in the WALs to allow the database to be reconstructed from a base backup plus the WAL logs. The archive mode parameter determines whether or not the WAL segments are sent to archive storage. When WAL archiving is enabled via the value on or always for the archive mode parameter, the shell command that we specify in archive command is used to copy a completed WAL file segment to archive storage. With an online backup, there's no need to shut down the database during the backup process. Instead, the WALs that are written during the backup are backed up alongside the database files in order to permit the restore of a consistent copy of the database. The basic steps are: tell PostgreSQL you're starting a backup, copy the database files and the WAL files, and tell PostgreSQL that you've finished the backup. So clearly, online backups have a significant advantage over offline backups in that the database is available during the backup process. So this makes them suitable for the majority of production systems. The disadvantages or potential disadvantages of online backups are that you need to manage the storage of the WAL files alongside the database files, and that you need to set your WAL parameters correctly. An extension of the online backup is continual archiving of WALs. So a base backup plus the WAL files allows recovery of the database to the state that it was in at any given time since the backup, as long as all of the WAL files in between are available. And this is what's known as point-in-time recovery, or PITR. A storage snapshot is essentially an image of a file system at a given point in time. Different storage vendors implement storage snapshots in different ways with different solutions, architecture and functionality. And the details of that are out of scope of this presentation. You would need to refer to your storage vendor's documentation to get the full details. In some organizations, I've seen storage snapshots are used as an alternative to database backups, particularly those organizations in which we have sysadmins or storage administrators rather than DBAs responsible for managing the backup and recovery of databases. This approach needs to be used with care because a storage snapshot has no knowledge or understanding of the underlying Postgres cluster. So with storage snapshots, it's important to consider the following. Ensure that your file system supports the ability to create a consistent snapshot of the data directory. The WAL files need to be backed up alongside the other database files so that the WAL log can be played when the backup's restored. Postgres will perform crash recovery when it's opened following the restore of a storage snapshot. In order to reduce recovery time, a checkpoint can be taken just before the storage snapshot. If the WAL files and data files are on different disks or you have table spaces on different file systems, it might not be possible to create simultaneous snapshots of all the volumes, and therefore this approach might not be feasible. It's essential to read your file system documentation carefully, and as with any other backup strategy, to test the entire backup and recovery process. The ideal is to consider storage snapshots as a method to backup files as part of a database backup using PostgreSQL functionality, and we'll look at that in more detail later. So moving to logical backups. A logical backup, otherwise sometimes known as a dump or export, is an extract of some or all of the data or the structure of the objects within the database cluster. This is dumped in the form of SQL commands that can be executed on the server in order to recreate the database objects. PostgreSQL provides the pgdump utility to perform this type of dump. Depending on the format used, the dump can subsequently be restored using either the pgrestore utility or PSQL or another client to replay the SQL commands that it contains. The advantages of logical backups are flexibility. We've got the ability to back up or restore individual databases, tables, or even parts of tables. And cross-version compatibility, and even in some cases, cross-RDBMS compatibility, because effectively we're just replaying SQL statements. On the other hand, the disadvantages are that a restore from a logical backup can be much slower than from a physical backup, and that point-in-time recovery isn't possible. So this slide recaps the features of the different methods. We can see, for example, that point-in-time recovery is only available if we're using continuous archiving. And we can see that the backup and restore of individual objects is only available with logical backups and dumps. So at this point, I'd like to do a quick poll to see what type of backup strategy everyone's currently using.
Great, thanks, Karen. So I'm going to launch the poll. Everyone should be able to see it now. As she mentioned, the poll is just asking what your current backup strategy consists of. So we'll give you all a moment to submit your answers. Looks like a mixture is a really popular answer. We'll be sure to put up the results once we get a good majority of answers. Wow, okay, so it looks like we have about 75% of you have voted, almost 80%. So let's close this out and share. There we go. There are the results for everyone to see.
Okay, so yep, a mixture is definitely a popular choice, and that doesn't surprise me because then effectively you can get the best of both worlds. Thank you. So as we discussed, a backup strategy exists to support your recovery strategy. It will define, amongst other things, the following based on the recovery requirements that you identify. Your backup method. So will you be using physical or logical backups? Will you be performing online or offline backups? Do you need continuous archiving? Will storage snapshots be involved? The frequency of backups. How often do you need to take backups? And this will be in order to be sure that you can restore your database in the amount of time that you have available. Do you need to take them daily, weekly, more often, less often? Will you be using always full backups, or will you, for example, use a full backup once a week and daily incremental backups in between? Your retention period, will you need to keep your backups just for a couple of days, for a week or a month? Would you perhaps want to keep them online for a week and then archive them and keep them offline for a year? So all of those, the responses to all of those questions will determine your backup strategy. There are many different backup and recovery tools available to support the different backup methods. But before looking briefly at some of them, it's important to think about what we actually want our backup and recovery tool to do. Amongst other things, we might want our tool to allow point-in-time recovery, to provide a centralized backup architecture, to schedule our database backups for us, to manage a backup catalog, to manage the backup and WAL files, to manage the archiving of our WAL files, to monitor our database backups and alert us if there are any issues, to provide compression of our backups and WAL files, to allow us to perform incremental backups, or to allow us to back up and restore individual databases, schemas, or tables. So in terms of point-in-time recovery, I might take my backups on a daily or a weekly basis. But even in that case, I would almost always want the ability to restore to any point of my choosing in between those backups. So if, as I can see in this schedule, I back up my database at 3 a.m. on a Sunday, Tuesday, and Thursday, I might have a batch job that runs at 10 p.m. on a Monday and corrupts the database. In that case, I'll have to restore the Sunday morning backup, but I don't want to lose all of the changes that have been made between 3 a.m. Sunday and 10 p.m. Monday. I can see I've had another batch job run and some OLTP in between. I'd want to be able to restore the Sunday morning backup and then replay all of the changes until a point in time just before the failed operation. A central backup architecture allows me to have one backup server that can be used to manage the backup and restore for multiple database servers. This will give me streamlined backup and restore management and a centralized store for my backups and my archived WAL files. Scheduling. Our recovery strategy might dictate that we need to take a full backup every Sunday at 3 a.m. and a daily incremental backup at 2 a.m. in order to ensure that we can recover within the required time frame. Although we can use a scheduling tool such as cron, it will be practical for our backup solution to manage the scheduling of our backups at the correct times. Backup catalog. This will list the various backups available to us, along with details such as the server that was backed up, the WAL files associated with the backup, the size of the backup, the length of time it took, the parent backup in case of an incremental backup. In case of recovery, we'd want to be able to either manually choose the most appropriate backup from the catalog or have our backup tool choose it for us. Management of our backup and WAL files. A backup tool should automatically remove obsolete backups and archived WALs, i.e. those that are no longer required according to the backup retention policy we've put in place. If, for example, I specify a backup retention of 7 days, I'd like my backup tool to remove backups and archive WAL files once they become older than 1 week. WAL archiving, I might like my backup tool to manage the archiving of my WALs for me. I might want it to ensure that the WAL files associated with my backups and those in between backups, if I'm using continuous archiving, have been copied successfully to my backup server. Monitoring and alerting. I want to monitor to be sure that the backups that have been taken support the recovery strategy that I've defined. I'd like alerts, for example, by email if one of the requirements isn't being met. For example, if the RPO or RTO can't be met by the existing backups. And I might want integration with other monitoring and alerting systems such as Prometheus, Zabbix, Nagios, PEM. I might also want my backup and recovery tool to allow me to back up and restore individual databases, schemas, or tables. I might need compression of my backups and my archived WAL files in order to reduce their storage footprint. And I might want to be able to perform incremental backups in order to reduce the amount of time and space taken for my backups. So an incremental backup will store only the changes that have been introduced between the previous backup and the current time. And each incremental backup will have a parent full backup. So now that we've considered what we'd like our backup and recovery tool to do, we'll have a look at some of the different tools available to us. There are various different tools available for physical or logical backup and recovery. And this slide shows a selection of them that we'll have a look at in more detail. But first, if you can bear with me, I'd like to do another poll to see which backup and recovery tools people are currently using.
Great, thanks, Karen. So let's grab our second poll for all of you. And there we go. We just launched it. So what is your main database backup and recovery tool? We'll just give a moment for all of you to vote. Okay, excellent. Looks like we have a good majority. So everyone get your last minute vote in. I'm going to close it out and share our results. So there we go.
Okay, so that's really interesting to me that a lot of people are using pgdump and pgdumpall as their main backup and recovery tool, over half. So most people are mainly using logical backups rather than physical to perform their backups. Thank you. So the first thing is that actually, in theory, you don't even need a backup and recovery tool. As we already saw, an offline backup can be taken simply by making a copy of the contents of the data directory whilst the database is shut down. It's also possible to perform an online backup using the PostgreSQL low-level API, either manually or by scripting the required steps. And I'll go quickly through those steps. So you need to be sure that WAL archiving is enabled and working. You connect to the database server and you execute a PG start backup, which will start the backup mode and perform a checkpoint. This connection needs to be kept open during the backup of the data files. You then back up the data directory using any convenient file system backup tool. So you can use tar, CPIO, rsync, storage snapshot. In the same database connection, you'll execute a PG stop backup, which will terminate the backup mode and perform an automatic switch to the next WAL segment. You'll have some fields returned by the PG stop backup. So you write the second of those to a file named backup label. in your root directory of your backup. And the third field will be written to a file named tablespace map. And you then need to be sure that the required wall files have been archived. If you've left the wait for archive parameter at its default value of true, there's nothing to do. pgstop backup won't return until the required files have been archived. If, on the other hand, it's set to false, your backup process will need to be configured to monitor and make sure that the wall segments have been successfully archived. Obviously, a script to include all of those steps will be slightly more complicated than that. It will have to include error checking and various different parameters, etc., etc. In practice, however, if you consider the list of requirements that we went through for a backup tool, this type of approach is extremely unlikely to provide you with the level of functionality or the assurance that you want in a production environment. So most people will use backup tools. So the first tool that we're looking at is the PG-based backup utility. This is provided with Postgres, and it can be used to take a backup of a running Postgres database cluster. It doesn't affect other clients' read or write to the database. It can be used for point-in-time recovery. It puts the database in and out of backup mode automatically, and it makes a binary copy of the database files. As with any physical backup, these backups are made of the entire database cluster, not individual databases or individual database objects. PG Backup doesn't itself manage a backup library. And by default, the wall is backed up via the streaming method during the backup. This slide just shows an example of the way that you can use PG-based backup to create, in this case, a compressed backup using the -z option of our database cluster. So we specify -h for the cluster to be backed up, and the -d to say where we're backing it up to. So there are various different options that you can specify, and it's well worth reading the documentation in order to understand them. It's a very simple way, a very simple method to create a database backup. If you wanted to restore from a backup that you've taken with PG-based backup, then the outline of the steps are to stop your database, empty the contents of the data directory and wall directory, copy the backup into your data directory, and restart the server. And the next tool that we'll have a quick look at is BART, Enterprise DB's backup and recovery tool. So this is a proprietary licensed product provided by EDB for managing Postgres database backups. The tool manages your backup policy, backup library, and restore options. And it integrates with EDB's Postgres Enterprise Manager, the PEM tool, so that you can take backups and see the status of your backups through that tool. So to use BART to perform backups, restores, and other actions, there's just one command, BART, that has multiple actions. So if you want to back up one of your servers, for example, it's just BART backup and then -s and specify the server name. Likewise for a restore. And then, for example, you can use show backups. So the documentation for the tool will give you a lot more detail. Unfortunately, this is obviously a very brief overview of each of the tools. I don't have time to go into a lot of detail on each one. Barman, Backup and Recovery Manager, is an open source Postgres backup and recovery tool that's written and maintained by Second Quadrant, or now EDB. It's a well-established tool, having been around since 2012. It allows remote backup and restore of multiple servers. So the ideal is for it to run on a separate mode or a separate node, or even on more than one node to allow for geographical redundancy of backups. Some of its features are the backup catalog, incremental backups, retention policies, archiving and compression of all files and backups. It allows you to use either archive command with the Barman wall archive or PG receive wall, streaming walls, or you can use both and allow Barman to compare them as a check. And it allows you to use either rsync or PostgreSQL PG-based backup protocols. A similar slide to the one I presented for BART, just to show that you again have one command, Barman, with multiple actions to do backup, recover, or for example, to show the backups that you have for a particular server. PG Backrest is another well-respected open source backup and restore solution for Postgres. Some of the main features: it allows parallel backup and restore. It can be used locally or remotely. You can perform full, incremental, or differential backups. You have backup rotation and archive expiration. Restores can be performed using a delta mode. You've got various different methods that can be used for the wall archiving. It provides support for table spaces and encryption. And there's also the option to limit a restore to just specific databases. So in general, we've said that physical databases only allow restore of the entire database cluster. Well, in some cases, you can use PG Backrest if you want to restore just a single database. But what this does is the databases that you don't want to restore, so the ones that you don't include in DB include, will be restored as sparse zeroed files to save space. And then after recovery, the databases that weren't included won't be accessible, but you can remove them with the drop database command. So it's useful if you want to create an otherwise empty database containing just those databases to be restored. But you mustn't think that if something goes wrong, for example, in just one of the databases in your cluster, you can't use PG Backrest to restore just that one whilst leaving the other databases in your cluster untouched. So with PG Backrest, a similar story. If you want to back up one of your servers, the different servers are known as stanzas in PG Backrest. So it's PG Backrest, stanza equals my server name, backup, and similar commands for restore and, for example, info if you want to see information on the different backups that you've taken for a server. There are actually a lot of similarities in the way in which the BART, Barman and PG Backrest tools are configured. So I thought it'd be useful to show some of the common architecture and setup, because it gives an idea of what's necessary regardless of the tool that you're implementing. So in each case, you'll create a backup super user on your database, on the database that's to be backed up. This could be called, for example, BART, Barman, or PG Backrest. You'll create a backup user on the OS, on the backup server, again, by convention, often called BART, Barman, or PG Backrest. You'll add entries to the database server's pghba.conf to allow connections to the database from the backup server. Set up passwordless SSH connections, or it can be any other unattended connection method, between the Postgres or Enterprise DB user if you're using EPAS databases. So between the Postgres user on the database servers and the backup OS user on the backup server. And you'll add the password for the backup super user to the PG pass file on the backup server. And again, you can use any other unattended connection method. It doesn't have to be the PG pass file. You'll create a config file. So these are called bart.cfg, barman.conf, or pgbackrest.conf, which will contain a global section. This is named BART, Barman, or Global in the different tools. And this will contain information related to all of the servers to be backed up. So it will specify the root backup location, the database user. It might contain default retention policy information. And then you'll have a server section, or it's known as a stanza in PG Backrest, for each of the servers that you want to back up. So this is, we can see in square brackets, the server name section. So server name is a name of your choosing to identify the server that's being backed up. And this will contain information specific to that particular server. For example, the host name and the data directory, and it might have retention policy specific to just that server, for example. And finally, each of them will have a similar backup directory structure. So you'll have your backup home or your root backup directory, often called /backups or something similar. And under that, you'll have a folder for each of the servers that you've defined in your config file. And within each server name folder, you'll have at least an archived walls and a backups folder, and others depending on the tool. Moving on to the tools for logical backups. So pgdump is a PostgreSQL client application that dumps or exports a single database, creates a file that contains the SQL commands necessary to recreate that database in the state that it was in at the time of the dump. The database remains available for reads and writes whilst pgdump's running, and a consistent backup's created, representing a snapshot of the database at the time pgdump began running. In its simplest form, you can see on the slide that the utility can be invoked just by saying pgdump, the name of the database, and point it to the file that you want to create. So you can see from that that pgdump writes to standard output. And by default, the output's a plain text file containing SQL commands. The files created by pgdump in this format can be read in by PSQL. So the second command that you see can be used to restore a dump. So you can just use PSQL to connect to the correct database and read in the dump file. Because pgdump and PSQL can write to or read from pipes, it's possible to dump a database directly from one server to another, as you can see in the example on the slide. So I'm taking a dump from host 1 and I'm piping it straight into my database on host 2. There are other formats available with the pgdump tool. So you can, instead of the text format, you can use a custom archive format, which can then be restored using the pg restore command, which we'll have a look at in one of the next slides. This we achieve by specifying one of the following values for the -f or format parameter. So we can specify C for custom, D for directory, or T for tar. You can also select just certain parts of a database to export by specifying -n schema or -t table options. A useful feature of pgdump is that its output can be reloaded into newer versions of Postgres and also into a different machine architecture. pgdump exports just a single database at a time, and it doesn't export any global objects such as role and tablespace definitions. Any global definitions must be backed up separately, and we'll look at the PG dump all utility for that. So PG dump all supports dumping the entire contents of a database cluster, including all of the cluster-wide data, as we said, for example, role and table-based definitions and access permissions. So in its simplest form, you can invoke the utility by simply saying PG dump all and pointing to the file that you want to create. This will generate the commands to recreate roles, table spaces, and empty database. And then it invokes PG dump for each database. As we've seen, PG dump creates a consistent snapshot of a database, but each of the snapshots won't be synchronized across the different databases. If we only want the cluster-wide data, then we can use the globals only option. And a point to note is that elevated, for example, super user privileges are required for invoking PG dump all. So PG restore is a utility that we can use for restoring a Postgres database from an archive created by PG dump, as long as we've used one of the non-plain text formats, custom directory or tar. It'll issue the commands necessary to reconstruct the database to the state it was in at the time it was saved. PG dump can be called using the command that you can see in the slide. And it will connect to the DB name database and restore the archive contents directly into the database. If you don't specify the database name, then a script containing the SQL commands necessary to rebuild the database will be created, and it will be written to a file or standard output. The script output from that is equivalent to a plain text output from PG dump. After you've used PG restore to restore a database, it's advisable to run analyze so that the query optimizer has up-to-date statistics. There are a number of different options available with the PG restore command, such as whether or not to exit if errors are encountered, or if you want the whole dump to restored as a single transaction, etc. So again, it's well worth reading carefully through the documentation for that. So in the following two slides, I've shown a comparison of the features of the different tools that I've talked about. On this slide, for example, we can see that Barman has an extremely rich list of features, including features to allow us to schedule and monitor our backups. And here we can see that there's only the PG dump option that allows us to restrict the backup to specific objects, with the exception of PG backrest, which, as I mentioned, does allow us to restore a specific database into an otherwise empty cluster. And we can see as well that logical database backup tools allow us cross-version compatibility. So just a few conclusions from the presentation. There's a vast array of different backup and export methods and tools available, but they all serve one main purpose, and that's to support your recovery strategy. It's important to think about your recovery requirements so that you know what you need your backup strategy to do, to make sure your backup strategy fits your needs. And your backup strategy might not be based just on one of these methods or tools, but you might need to use several to make sure that you get everything that you need. So thank you very much. That's the end of my presentation. I hope it's been a useful overview of database dumps and backups, and I'll be happy to answer questions if we have time for questions. Courtney?
Yeah, sure. We'll do about 5 minutes of questions just to give people time to get to their next meeting. And also, I just wanted to review a few questions came through about the recording and the slides. So yes, everyone will get access to the recording and the slides, an email will go out later today to the email address that you used to register for the session. So not a problem there. Okay, so now let's dive into some of the questions here. Let's see. So one person asked, is backups only useful in emergency scenarios, or can they be incorporated into daily procedures like cloning to test or migrations?
Yeah, so absolutely they can be incorporated into that kind of procedure. The main reason that most people see for backups is for disaster recovery, and obviously that's essential. But yep, they can be very useful to create clones of your database for development or testing.
Okay, someone else just wanted to clarify, is PEM an EDB tool? So.
Yes, PEM, Postgres Enterprise Manager, is an EDB tool.
Wow, lots of questions coming in really quickly. Hold on. Let's see. Let's go with, if a source database is full of bloat, will restoring from a PG-based backup copy contain that bloat?
So yes, because PG-based backup creates a physical copy of the data files, if you've got bloat in those files, then that will be copied to your restored database. If you need to be able to remove bloat during a restore, then you'd have to do a logical backup for that. So export the data using pgdump, for example, and then import it.
Okay, someone wants to know if there's a way to test or check backup integrity. How can I check if the backup is corrupted?
So almost all of the backup tools will, almost all of the backup tools do have a check option. So the backup commands that I presented, there'll be an option in there that includes a check, so that you can check them for corruption. I don't have the specific details of how it works for each of the tools, but yes, there is a way to do that.
Someone else said they haven't used physical backups since version 9.5. Are there many changes until version 13?
Yes, there are changes with PG base backup. No, not with PG backup. With the low-level API, for example, the exclusive backup mode has been deprecated. I'm trying to think of specific examples. I'm being more of a Postgres newbie. I haven't worked all that much with versions of Postgres pre-10, so I might have to come back to that question.
Yes, and just as a reminder, because we had a ton of questions come in at the last minute, that if we don't get to all of your questions, we will follow up with you after the fact. So let's see. Someone else asked, if I'm using a remote backup server, do I need to install my backup tool on my database servers?
Yeah, so that differs tool to tool, but the general answer is yes. You'll have your backup tool installed on your remote backup server, but then also certain operations will be performed on the individual database servers. So for some tools, you need the full tool installed on each of your database servers, and for others, you'll maybe just need a specific database server version of the tool. So Barman, for example, I think has its Barman CLI package. With BART, for example, the only time that you need BART installed on the actual database server is if you want to restore from an incremental backup.
Okay, so we're right at 10:55. I want to give people to have a break before their next meeting. I just wanted to say thank you, Karen, for joining us today. And thank you to everyone that logged in and joined us live. We'll send out the recording and answer all of your questions. We hope you have a great day. Thank you.
Thank you.